Data nerd, how's it going? Wow. Someone's in here already. Okay, so this is another continuation. I'm gonna keep this a little bit more efficient. Yesterday was just, my mind was tired, I was really slow, I was not efficient, my thought process went haywire, going way too deep into the rabbit's hole, and also let me know if the sound is okay because I'm not sure. But today I'm actually streaming a little bit earlier. Usually I stream around 7 p.m. but I really feel like streaming that late at night, I need to get used to. I need to do more discipline. I mean, be more disciplined about that. But today I have to do it earlier because I'm going to a meetup later today. So I'm just going to work on a little bit more of this. We're still working on that Pokemon Kaggle. Someone from Slack told me that I should use the use kernel instead in the actual Kaggle website. I think I should do that. But before we start, yeah, me too. I like to listen to this kind of music too. How's it going, data nerd? I'm assuming you're a nerd about data. Me too, man. But I've actually found something very, very interesting during my off time. There's a research paper by Jeremiah Douglas Johnson who did an MMA fight using logistic regression model. So I think, I haven't really read the whole thing, but I'm assuming that, let's see here, he was using logistic regression because he wanted to find out whether if one person versus another person, and what's the prediction of that, of who's going to turn out to be the winner. And I think that's actually kind of interesting because it's very similar to the Kaggle Pokemon dataset, because it's just the same thing. You have Pokemon battle fights and you want to predict the outcome of the battle. Whereas this guy did an MMA fight, mixed martial arts on UFC, and try to predict the person who's most likely to be the winner, you know? So yeah, see, their model attempts to he also researched other resources, and their model attempts to predict win-loss outcomes in basketball or NCAA tournaments. So this is nothing really new. Obviously, it's no surprise because the Pokemon Kaggle dataset sounds really like educational mostly instead of real world. But I mean, who's to say? Let's see here. I want to see if there's any statistics. Okay, the goal of the paper is to forecast win-loss outcomes in MMA fights, just like the Pokemon. The model will be significant. Okay, whatever. Model will be significant better than a simple model based on winning percentage. But he did use a binary predicted variable, which is basically logistic regression right here, which is good. I'm glad that we actually went to that direction of log regression. Oh, here we go. Oh, this is the statistics version of it. That's just the statistics algorithm of the log regression. yeah, and then there's like these different independent variables. Takedowns landed. Maybe they're independent, I'm not sure. I've also noticed that like they use pairs to find or is this to find the correlation, if there's any correlations. That's great. You know, I kind of need to find out how to do that in R. I only know how to use it in VIF, but then you have to create the GLM formula to do that before we do that correlation stuff, I think. But you can use pairs too, just to see if there's any relationships between two independent variables too. God, I need to study what chi-square is. Anyone know what chi-square is? I learned it, but I completely forgot. Oh wow, less than 0.01. Oh, anyways, the very fact that you can use fight data and using logistic regression is perfect for what we're trying to do anyways. So let's go back to our R. Oh, yeah, so, yeah, okay, so before we get started, I kind of want to recap of what we did. Yesterday was a nightmare. My head was not right. But, what we did is basically, okay, we basically had two CSV files, Combats and Pokemon. Combats is just a simple file where it just has first and second Pokemon and then the winner. But what we did is that in the Pokemon.csv is all the metadata, right? The metadata of this kind of stuff, like Bulbasaur, Grass Pokemon. So we kind of used the join function to just attach the unique identifier to the actual metadata. But then for the first and the second Pokemon, and attach the dependent variable, which is our winner. So that was yesterday, and then we found out yesterday, or no, that wasn't yesterday. That was 4 days ago. But then yesterday, okay, so this is what it looks like. Ooh. This is what it looks like at the end, like all these headers and stuff like that. But yesterday what we did was, did we not save that? Oh shit. Oh, I don't think we saved it. Are you serious? We didn't save it? Oh, hell no. We didn't save it. That's okay, I think I know what to do anyways. It'll take about 10 minutes this time instead of like fucking 2 hours yesterday, God, just to figure some shit out. I know this is a lot of attributes, a lot of headers, but what we found out is that we need to standardize classification types, such as, you know, Pokemon data types and then their second data types, as well as the other Pokemon type and then the other second data type. We're probably going to feed this into the logistic regression and summarize it and really find out whether if any of these are, if their p-values, if we summarize it, it displays the p-value, and if it's anything greater than maybe like 0.1, usually 0.05 is the thing, we're going to keep it. But if it's, no, if it's less than 0.1, we're going to keep it. But if the p-value is less than, if it's greater than 0.1, we're gonna lose it. If it's less than 0.1, we're gonna keep it. God. The reason being is because there wouldn't be any statistical significance. There just doesn't have sufficient evidence to support that this that particular attribute or dependent variables has statistical significance into our model. But before we do all that, in fact, before we do anything, what was her name? Rachel? We're not gonna use RStudio anymore. I think we're gonna use kernel. So this is actually my first time doing this. The only reason why I'm a little apprehensive doing kernels because I don't want people to see my shitty shit stain of data analysis. Everyone's so amazing. I'm such a noob. Let me know if the music is a little too loud or my voice is a little too loud. Thanks, data nerd. How did you find out about my stream? Was it from Slack? Ah, okay. Good stuff. How are you doing? Like, how are you? I bet you're like an elite. So, how are you on data analysis, data science stuff? Because I recently graduated as a master's in University of Wisconsin, and I still feel like I'm not even close to even being good. I feel such a noob. Why do I need tidyverse? I don't want that. What is this? This R environment comes with all the CRAN and many other helpful packages pre-installed. You can access files from datasets you add to this kernel in the input directory. Okay. Input. I'm so confused. What do I do with this? So where's my CSV files? Do I just no. Your commit isn't good. Click commit to execute to top to bottom share. Okay. Hey, that's good. I'm trying to find a job that does that too. Finding data analytics, part of like creating reports, visualizations and stuff. Yeah, me too. I think that's my strongest point. I'm not proficient with coding at all, so I'm not confident to put that in my resume or anything like that yet. Nice. So you know a lot. Like all these algorithms, right? Like random forest, decision trees, SVM. I'm still trying to learn that kind of stuff, and I already graduated. And I forgot most of what I was supposed to do. Anyways, well, I hope you get that DS job. There's a lot of people that are, there's a lot of companies that actually are in need of someone to work with data these days. I myself is trying to become one as well. I'm so confused what I'm supposed to do. I need, how does it work? Like, where's the CSV files to do this? In a notebook, you can run a single code cell. Okay, blah, blah, blah. Shift enter, okay. I use Python. Okay. Like scikit-learn for machine learning or Keras. You can access files from datasets you've added into this kernel. You can see files added to this kernel by running the code below. Can't I just... Oh, right here, add data. Ugh. Oh, it's already loaded in here. Ah, I got you, fam. Huh. Scikit-learn, nice. Maybe I'll learn scikit-learn way later, but right now I've been educated in R, and I forgot everything in R, so I really don't know anything, but I'm not like 0%. I'd rather be more comfortable with R because I kind of, it's just a little bit easier to look at the summary of the models. And I have no idea how to do that in scikit-learn. I know you have to like import a library called stats models, I think. That's not really scikit-learn, that's a package. Are you trying to for TensorFlow and Keras, are you trying to start digging into deep learning? Especially for TensorFlow, I think that's really strong for deep learning because it's really robust. Does this work? Is it like this? How do you do the path? This is my first time doing this. Forgive me for feeling confused. Oh! Come on. Copy path to clipboard. Oh, okay. Oh, that's all you do? Okay. Gotcha, fam. And I'm assuming, assuming it's like this too. Academics will definitely use R mostly, for sure. I've heard of that too. But at the same time, like, whatever gives you results like the most easiest, most convenient, without any repercussions, I think that's the best tool. Whether if it's Python or R. Come on, let's just test this out. Okay. Hey, I kind of like the output of this. Yeah, R is actually not hard to learn. If you know Python, R is a little different because, I mean, if you're used to like data cleaning and munging using pandas for Python, R is slightly. If I compare pandas to R, I think for small data, I think R is better, in my opinion. I mean, just the very for me, like I don't really know much, but when I combine like certain columns and stuff like that together, it's just one tiny line of code for R, or you don't have to always instantiate that, data.df or df. Whatever to instantiate it as a data frame. Okay, what am I doing? All right, I'm stalling. Sorry about that. I'm a little confused. Is this code or Markdown? Okay, this looks like IPython notebook style. So how do I add? So I'm shift entering. Can't even use. The following objects are maximum combats, first, second, winner. Do I need to know that? What is the point of that? I'm just learning as I go. I've never used... I don't want to commit, man. Yeah. Okay. I don't know what's going on with this. I've never seen this thing before. Following objects are masked. I don't care. Go ahead and mask it. Alright. I can use plier, right? You have loader plier after dplier. This is likely to cause... Oh my... attaching package plier. Do I really need to see this? This is kind of annoying. Huh. Is there a way to turn that off? This is so weird, man. Okay. Honestly, I feel like I can perform faster just using RStudio. Sorry, I'm just copy pasting right now. I'll tell you what I did so far after I finish copying and pasting, but I'm so new to this kernel stuff. I'm a little confused, so forgive me for not going any faster. It does look, it is a little bit like IPython Notebook, a bit. What? Why do I have this?
You know something? Everybody is always waiting for everybody else to take a chance because they're so afraid.
Sorry, I'm just gonna remove this column for now. What did I do? New Pokemon Combat. A equals. How many is there? Oops. Was it some? Nope. Ah, just dim. 10. 10. Oops. 26. Gonna do this. What? Did I do something wrong? Oh, hell. That's not what I was supposed to do.
Just you. But on that day, when I came back home, the only thing there was that pocket message. That and a small piece of paper that had just one word written across.
Dang it. I guess I'll have to start over.
For some reason,
That's kind of weird.
I didn't feel sad. It just didn't seem real. But slowly I realized that it was real. That you were gone. And little by little, I felt something inside me go.
I'm almost done. I just need to stop being a retard.
Made a kind of bet with myself that I would leave this planet and start a new life. If you didn't
Okay.
by the time the watch stopped,
How do I remove this? Oh, okay.
disappeared as that.
I don't get it. Is that what? Well, what the hell? What did I do to make it right? Okay. All right. Oh, that was weird. Okay. So this is what I finished for now. Or I did work yesterday. All of a sudden I didn't save it, and so that was my fault. I kind of need to retype the work that I did yesterday. But 4 days ago, this is what I did. So just the usual, import the data using Pokemon and combats, and you can attach combats and Pokemon. Attach means that you don't have to instantiate the data frame, or whenever you want to call like, let's say for an example, an attribute or a column, you don't always have to type in this data frame dot column and then do whatever that you need to do. You can just put in column and then it'll just know exactly what to do and stuff like that. But I guess this is kind of moot point because later on I'm just gonna make a new data frame anyways. But anyways, I've downloaded this thing called PLYR in R. It's basically a tool set where it contains this function called join. So again, like the data set actually has, I think you've seen it, right? It has the first column and the second column and the winner, right? These numbers are unique identifiers to the specific Pokemon, and this column right here is a unique identifier that associates with the different type of Pokemon too at the same time, right? So Pokemon number 1 is Bulbasaur, blah 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 blah. You know the drill, right? 66 is Poliwag. What that means is that if I import PLYR, I also imported this function called join, where I can actually attach those unique identifier columns with the metadata side by side, combine them, and so I've basically joined or merged, and then just changed the column name, the first Pokemon and the second Pokemon, and then so these are like two different vectors, similar to data frames. And then once I did that, like I just attached it all together into one huge ass data frame. And so basically this is what it looks like. Like that. All that. Remember how it turned into just one little dealio? And then now it just turned into this big damn thing. The reason why I want to do that is because, like, I guess these are the factors that I need to feed into my logistic regression model. I'm not done yet. I still need to clean up data, which I did yesterday, and I completely did not save it, so I have to start over, but it's not going to take long this time because I know what to do now. Oh man, yesterday was a nightmare. Anyways, let me know if anything is confusing so far. It's already 37 minutes past. Oh my goodness. I just have to change this. Blah blah blah. Hold on one sec. I messed up. Oh no, I didn't. Holy shit. Oh no. I'm a retard, man. Guess what I did? I just copied paste from the wrong code. But I mean, that's okay. Because it wasn't that much different anyways. I can still go on, so not that big of a deal. Now, what we need to do though is, because we're going to feed this into a logistic regression, we got to instantiate our classification data. So if you specifically look at this, the first type 1, it has rock, grass, fairy, fire, and stuff like that. And this one even has null data. But we can easily fix that. I did that yesterday. What we need to do is just basically vectorize all the columns, or not the columns that have classification data, into a number, a label that represents a number that represents that title and stuff like that. I know that there's 18 of them because I just found that out yesterday. Let's see here. Yeah, so there should be 18 different 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, there's definitely 18 different things. Oh my god, why am I doing that? Is there such thing as a summon or? Oh. Maybe dim? I'm trying to figure some shit out. Whatever, I don't care. I'm being off tangent again. Anyway, there's 18 different types of types, apparently for type 1. Anyways, you get my point. What we're gonna do is that we're gonna put this as an as numeric. So there's this function called as numeric, which automatically easily converts any type of classification label into a number. And I did that yesterday. I found that out the long way. It took me 40 minutes just to fucking figure that out. I was trying to figure do all this like weird ass like definitions to do that and stuff like that, but apparently R actually has a function like that already. So what we're gonna do is just copy paste. Oh, not new combat data. What's called new Pokemon combat. So this as numeric function just converted this type 1 with the rock, grass, fairy, fire types into its corresponding number. So if you look at new Pokemon Combat now, yeah, it'll have class type 1 right here, right now. What just happened? Where's my dependent variable? Did I not do? Oh, I didn't c-bind this, did I? But I did. Holy shit! Why am I so retarded? Okay, hold on. No, I'm just gonna fucking start over. Excuse me. Choked on saliva. That's how retarded I am. Okay. Let me copy paste again. Let me start over. Give me like 5 minutes. So embarrassing. I wish there was a more elegant way of doing this, since I'm so new at doing all this stuff. This is what I wanted. Okay, so as numeric, like I said before, now if I did this, it'll turn into I just created a new column called class type 1, which converted to this type 1. So rock represents class number 16, grass represents 10, fairy represents number 5, fire represents number 7, rock represents 16 again. Because rock and rock are in the same place and they're both 16. That makes sense. So we're going to also do that for all the other classifications data points. So type 2, there's also other, there's like 5 more I think that we need to figure out. So luckily I did all that yesterday. Is there a way to show all of the columns? So, legendary class means that if the Pokemon is a legendary type, it's false, otherwise it's true. 1 is false, 2 is true. It's just a binary classification. There's class types. How do I show all of the... I'm gonna ask this. By the way, I think I only have... No, I actually have plenty of time. Never mind. Right now I'm asking someone to help me out. Okay, so I think right now main type 1, type 2, HP attack. Winner is the dependent variable. What I gotta do now? I wonder what some good questions are. I mean, are we ready for EDA? So, right now we don't have to use type 1 and type 2 anymore because we've instantiated to its corresponding numerical labels. What else is there that we need to fix or clean or restructure or something else? What do I gotta do now? Should we just go ahead and build the model? I have a feeling that that's not what I'm supposed to do first. Man, I wish I was more experienced. So now we are at what we are now. Now if we could feed into all these types minus the words and I know what we should do. We gotta clean up the winner, the dependent variable winner. Since we're gonna perform logistic regression, this doesn't make sense if you feed the dependent variable to this. It's because it's supposed to be a 0-1 binary output. So that's no big deal. What we can do is convert if so like if winner is or where we could attach a new column 0 full of zeros, and if x where x which is it which or where? It's either which or where, I forgot. Okay, where or whatever x dot equals
this is going to be such an exciting day.
Winner,
I hope you enjoy.
then that would be 1. Otherwise it would be 0. Wait, hold on. No, okay. It'll be full of 1s, but it'll be 0. So if it doesn't, if x does not equal, I'm thinking too hard, man. All right, let's just do it. Let's see here. What should we name this? Instantiated winner? Binary winner.
It's going to be life, there are no
New combat data binary winner equals new combat data. Oh no! Before I do that, let's do.
We are the dreamers of dreams.
One, right? Yeah. So.
If the good Lord had intended us to walk, he wouldn't have invented roller skates.
Let's see. Yeah, so everything's full of ones. But because that doesn't work out, we could just do new combat data. Is it where or which? Is it which? It's which, isn't it? Yeah. Okay, 0 means that the second Pokemon won. 1 means that the first Pokemon won. So it's based upon the first Pokemon. If the first Pokemon won, it's 1. If the first Pokemon lost, it's 0. So this isn't right. This needs to be X2. So if hopefully this works. I hope this works. Is this gonna work? I doubt it. I knew it. Oh man, I am such a noob. Do I just do that? This doesn't. This would not make sense, would it? No, I messed up, I think. Hold on one sec. I'm such a noob! No. No, I did not do it right. What the hell? It's fucking dumb.
The next day, I thought.
Alright, let me start over.
So much that still to this day, I feel that every morning when I wake up.
Thank you for watching, and good night.
How do I do this again? New combat data. Let me look something up. It's like a filtering system. Maybe I should just do it in a weird way. No. Let's see here. Combat data. Which... Does that work? Oh, bad feeling about this. Yeah. I think I did something wrong. How do I do that? I'm learning as I go. If anyone knows, let me know. Ask me questions, please. 'Cause I'm so confused.
It was all a dream.
Is it like... Is it like this? columns with labels of pre-existing columns trace back.
It was all a dream.
Maybe it's not supposed to be which. I need to read more about the which function a little bit more. Hold on one sec. Letters equals G7. So is this like a filter?
It was all a dream.
Do I just take this out? No, that doesn't make any sense. Oh god, I fucked up. That makes sense. Well, that makes sense. That is the index numbers. But if I did this,
Ich sehe die ernsten Künstler, die wirklich ihre Sache bearbeiten. Und was bin ich eigentlich? Nur ein Schnellkünstler und so weiter. Die Produktion. Aber das Denken.
man, I'm such a noob. What am I, man?
Es gibt eine Leitfaden.
I have to look at some art documentations. Maybe which isn't really the most.
Und davon kommt vielleicht auch mein
I wonder if there's a better idea than what I'm doing. Apparently I'm still a noob in data wrangling. You don't need to use a witch? Really? You don't need to use witch? Are you sure? Oh, that's R-bind, huh? Oh God, come on. Okay. Alright, I guess I'll have to just look at my resources then. I was trying to find it online, but man, that's annoying.
We're going to be at Computable. So, we're going to take a look at the full options that the others have in ventilation, which predicts the response. So, and the 26 observations at the end of here. Alright, so the next thing we're going to do is randomly assign these such that CV groups is one. Here's what we would get. Groups assessing. So now we're going to take a look at it. That's we're going to make use of that inside our actual cross-validation.
I mean, how is that any different than what I did?
Each of the CV groups in turn and fitting the model on the remaining data, then predicting the data within that particular CV are values from the cross. My first group. And true, the group is value bias, in this case 1. Then we're going to fit your model using the full model as we had before using
I still don't understand. Can I just do this? Why can't I just do this? just do this. Can't do that. Huh. I'm doing something wrong. I know this is... It should be easy. It's like right there at my fingertips. I just really can't find out how to do this. It's like such an easy thing to do, and I don't even know how to do it. It's so annoying. If I can... Oh. I can't believe that fucking worked. Man, horror is so weird, man. Seriously, oh god damn. Oh my lord, man. Huh? Oh no. I didn't mean to do this. I did not mean to do that. Let's start over. Boom. 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 Let's see here. $266,298. 266 versus 298. If the first player, which is 266, lost to player 2, 298, then and then winner is 298, then it would be 0. So the first player lost. Second player should lose too. 701, 701. Okay. 0. I'm just double checking here. 668, 668. Yep. She lost. 683, 683. She lost. But Omastar. Pokemon number 151 versus Pokemon versus 231 Shuckle. Master 1 actually, right? Wait, where's my winner? 151, which is Shuckle. No, Omastar, I mean. Shuckle lost. I remember this, there was this like, there's this YouTube video called Dorkly. And then there's this thing called like Pokemon Red. It's like some nerd. Like there's a character that's depicted as one of the Pokemon characters, but the caricature is very like, he's very loserish in Dorkly. And then they kept making fun of Shuckle because he's such a happy-go-lucky Pokemon where he's so naively happy that like everything that goes supposedly go wrong with him is, it's not really wrong for him. It's just that he's always happy. He always just says yay. Reminded me of Shuckle. You should watch that. The Dorkly series is hilarious. Anyways, I finally converted to binary winner. Zero means they lost, 1 means they won. So we're gonna use this as a dependent variable this time. Because we converted the winner into binary now. In fact, I'm gonna actually write that. Binary winner. 0 means Pokemon 1 lost. First Pokemon lost. Alright. Oh, that took such a long time to figure that out, man. It's so weird. I gotta really remember this kind of like style of coding. It's so weird. First you create a data frame full of ones, 50,000 rows of it. Then all of a sudden you can like say, hey, put it into a bracket, or not a bracket, closed, is it a bracket? Of this other filter that we could do and make that into 0. And then once we have that binary winner, we can actually put that into the binary winner that we declared. This is such a weird type of coding. I'm so confused sometimes. Like why? Where did this filter come from? Like, it's so weird. I'm getting hungry, guys. Again, we accomplished so little, but we were making progress. It's like baby steps, like half a step forward. Yeah, half a step forward. No falling back. It's just stupid shit like resetting the data frame, which is bad. Oh, I think I might need a break, like maybe a 15-30 minute break. I'll go for 15 minutes. I'll be back in another 20 minutes. And then I think we can resume to do EDA. Electronic Dance Association. Just joking. Exploratory data analysis. EDA time, finally. Jesus Christ. I don't know what that is. I'm just supposed to be. Never mind. Stupid. I'll be back at 420. Yo. Well, to be honest, I don't know if it's EDA time yet. I'm hoping, but I think we should seriously move on because I feel like it's good enough. We have instantiated our dependent variable into 0 and 1. We have instantiated all the classification data points into numbers. And we have all these attributes. What we do now? What we gotta do now? Excuse me, I just ate. What we gotta do now is... let's do this, baby! Let's GLM it, I think. I don't know. I hope I'm ready. I feel like I'm missing something that I don't know of and somebody needs to help me out here. But, unfortunately, I don't remember how to do this, so I'm just gonna quickly review some shit. What we gotta do now, man? What we gotta do? I know what a linear model is, so this is a little log of whatever that is. We don't normally, I don't normally want to fit all the data into the GLM function because it'll just be prone to overfitting the model. However, I just want a snapshot. So let's just do it. I didn't know that GLM is already loaded into base R. Anyways, let's do that. So we're gonna fit the full data in here. I know that's not the right way to do it now. I know, guys. I know that I have to split the training and testing or even do cross-validation. We don't need to do bootstrap because 50,000 points or 50,000 rows of data, that's good enough. We don't need to generate new data. But just to get a snapshot, in a perfect world, we're just going to use all the data. So, I forgot the syntax of this, so I'm just going to do fit equals GLM, new combat data. Alright. We are not going to use any names, any Pokemon names. You know what? No! We are not going to do this yet. We are not going to do it. Sorry for that cock tease right there. What we're gonna do is, you know, if this is Jupyter Notebook, can this pop out graphs? But there is no linear correlation. How do you measure, how do you detect linear correlation? Or correlation, or anything? Can't really, because all of the variables are independent of each other. I know that for a fact. There's no way. Attack, defense, speed, generation. I am not going... Okay. Fuck it. We're not going to do correlation right now. I mean, if you do summary of the model, it'll show you most likely what it is. You'll just get an idea. But we're going to use... Alright, we're just going to go ahead and do it. Never mind. Back to cock teasing, not cock teasing. Actual action. New combat data. And then... I feel like I'm missing a lot of things that I need to check out first before I do this. I mean, most of the assumptions I'm assuming are past. I'm assuming that the log odds are generally linear, whatever that means. Oh, we're not using generation. We're using speed. We're not using type 1 and type 2. What the hell am I doing? So we're not using any type 1 is actually class type 1 actually. So class type 1 plus HP plus attack plus defense plus. Is it class type? Alright, GLM, new combat data. Not new combat data, what am I doing? It's binary winner. Here we go, binary winner. Class type 1, class type dot 2, HP attack, defense, SP attack, SP defense, speed. We're not gonna use generation. I mean, it seems like it's already mixed in, so what's the point? None of this stuff, but legendary class though, we do need to add. Legendary class, HP 2, and then class type dot 2 underscore 2 plus class type dot 2 underscore 2. There we go. HP 2 plus attack 2 plus defense 2 plus SP dot ADK 2 plus SP dot DF 2 plus speed 2 plus legendary class 2. And that's it. And then data equals new combat data, and family is definitely binomial. Oh shit, that was fast. Well, holy shit. Wow. Holy shit. Holy goddamn. Oh my god. So you're telling me first of all, almost every single variable has statistically significant. Every single dependent variable is almost statistically significant. That is the most insane thing I've ever seen in my life. I think I have overfitted the model. This is way too accurate. So all of these attributes are relevant. You can fit all of these attributes into that model. The only thing that doesn't really have that much statistical significance is SP attack and SP defense. That's insane. Wow. SP attack, well, that doesn't make any sense, because how come SP attack 2 and defense 2 works? How is this so high? Did I do something wrong? Okay. So we just fitted our logistic regression model into this, and then we're actually looking at the summary. I'm just reading about log regression, what I gotta do. So this is statistically significant. SP attack and SP defense are not really associated with the probability of the first player losing. But this does. Or the second player. Huh. Before we do any cross-valid, like, okay, so this is fitting the full model, so obviously this is overfitting. This is definitely prone to overfitting the model. Look at the AIC, it's too high, man. Way too high. I think in relevance to, I have no idea actually, but I know for a fact that we just fit the full model, so that doesn't even really count. But we are giving a snapshot that most of these attributes are associated with the first Pokemon losing or winning, well, which affects the probability of the first Pokemon lost. Now, how do we estimate this though? We've already fit the model. Now, let's see the results. Need to test something first. How do I predict? Work. My browser froze. You can wait for them to become responsive or exit the pages. Just exit the pages. Well, at least it's saved. Wow. Let's go, baby! That actually worked. Fit type response because it fit all of the data anyways, right? So let's do something first. What we're gonna do is all the prediction values. Just gonna rep, I don't know. Then what we're gonna do is okay. So we have all the predictions now. What we need to do is let's create a table. So you know these predictions, if it's closer to 1, that means if it's closer to 1, that means player 1 won. If it's closer to 0, that means player 1 most likely lost. Maximum likelihood of the first Pokemon lost. So what do we gotta do? We gotta create a table, right? Table. Prediction values. If prediction values is greater than 0.5, which means that they won, from what's called new combat data binary winner. Okay. Here we go. This is our results. So, false and true, you know what this means? That means if it was correctly predicted, compared to the true data, the true data. Again, this is just full data, so it's definitely overfitting, but we're just still trying to create a snapshot here. But if there is a false, so I'm looking off of this thing. Okay, I'll show you. This is what my school notes said. I'm cheating a little bit. If you can't calculate all the truths and all the falses, the rate of false positives is this bottom number divided by this the total of this part, all the nodes, and then this is the true positive rate, which is the power sensitivity. In other words, our model out of all the 50,000 data points, let's see here.
Life moves pretty fast. You don't stop and look around once in a while, you could miss it.
That means this model is only 11% accurate! Oh, that sucks. This model is only 11% accurate. This model is only 11% accurate, guys. And I just fit the full model. It's not even like cross-validated. If I was even cross-validated, it would represent even a truer error rate, which means it'll probably even be way less. It's only like 8% accurate. But what is the false positive rate? Let me check. You do 2649 divide by 2649 plus 23750. Well, there's 10% of false positive rate. The true positive rate is basically the other side, so if the first player won, or the first Pokemon won, it would just be this. You know what? I miscalculated. It's not 11%. My bad. This is actually wrong. I didn't do it right. 20728 plus divided by 20728 plus 273. What the hell? We got an 87%. We got an 87% chance of a true positive rate. That's fucking amazing. So our GLM model, adding all those attributes, we have an 87% chance of confidence that our model comes out with a true positive rate. You're kidding, man. You're fucking with me. This is why, like, well, alright, whatever. I'm looking at it, but I just still can't believe it, man. Why do I feel like I'm doing something wrong? But I have only used 0.5 as the threshold right here. We're using this as a threshold for 0.5, 50%. If we increase the threshold to maybe like 0.7, let's see what's going on right there. Actually, I'm gonna put this in a new cell. Okay. So we have, so the false positives is this stuff. 0 means that they lost, but it predicted that it was true. That 0 means that the Pokemon, the first Pokemon lost. 1 means that the first Pokemon won. So, but then our GLM model up here, which is the full fifth, which naturally just means that it predicted true when it's supposed to be really false. Or it predicted true. It predicted that the first Pokemon won when in reality the first Pokemon lost. And then in the false, is that right? Oh yeah. So yeah, right here. Never mind. Okay, let me start over. So 1,409 Pokemon on a threshold of 0.7. 0.7 means that there's a 70% chance of how they won. Is that 14,009 data points have falsely thought has incorrectly predicted that 1,409 values are defaulted to that the Pokemon lost, when in reality it was true. Wait, I said that backwards. I'm so confused. Let me read something first before. Let me get my mind right. Okay, this one part is like where where the first Pokemon won. So it's saying that out of all the Pokemons, out of all the first Pokemon who really won, what fraction were we successful at predicting? So using a 0.7%, basically a 70% threshold, we can calculate it pretty easily. 16303 divided by 7298 plus 6303. 70%. That's fucking amazing. We have a 70% chance that the challenge for using the full model. It's only if we use the full model. If we use all of the things, maybe if we took out this, maybe it'll be higher. It'll be generally higher, wouldn't it? Oh, this part though, like this column though, basically means that out of all the first Pokemons that did not win, what fraction were we unsuccessful at predicting? That's really good. That also means that, okay, if we did that, so 1409 divided by 24990 plus 1409, we'd say that only 5% was incorrect at predicting using the full model. This is no surprise because this is the full fucking model, man. This doesn't count. But I'm really surprised how strong the associations are with basically all of this except this one, SP defense. All of the attributes. That's insane. Granted, we do have 50,000 data points, so I think that's really good. Or 50,000 rows of data. 50,000, n equals 50,000. So if we increased our threshold to 0.7, we actually lowered our success at predicting. The false positive is 0.5, but this is actually more true because then it's not 87%, it's more like 70% actually were successful at predicting the model. So that's not good, actually. If it just went down to 87, we need to maximize both. That's actually not good. I just learned that just now. I'm learning as I go. So this is actually bad because it just went from 87 to 70%. However, it went from 0.1 to 0.05. So you're supposed to really maximize it, not unmaximize it. So let's say if we went down to 0.4. Did I do something wrong? So we increased it by 0.16 for the false positive. And if we did it for the true positive, be 93. I mean, naturally, if you did 40%, oh, what happens if I did 1? Is it just always going to increase the lower it gets? Whoa. No. This actually went super high, 54%. Oh, what the hell? So, yeah, okay. Yeah, you're right. Never mind. Man, if anyone can help me explain how to set the correct threshold, let me know. 96%. Yeah, if it's anything below, so the threshold, it might be a little irrelevant, to be honest. Oh, okay. So what constitutes a good threshold? That's a good, okay. So we know that 0.5 is actually pretty good, 87% chance of true positive with 11% chance of false positive. That's extremely well, but what constitutes the most accurate threshold? And there is a thing called the ROC curve, based upon the confusion matrix that we just created right here. So let's do this. My ROC equals ROC response. Our response was new combat data to binary winner. But our predictor is prediction, what was it again? Prediction values. No validated provider, what the hell? Oh, whoops, response. Let's try it again. There we go. And we can plot it. Let's plot this. Plot.roc myrock. Wow! Alright, let's see if I can make sense of this right now. This is an ROC curve. ROC curve actually measures the threshold of the true positive or the false positive rates. So, if we increase our threshold high, our sensitivity, in other words, our true positive rate increases. So if we increase it to like 0.6, we'll have a really close representation of like it's like 0.9%-ish. If we increase our threshold to 1, I guess it doesn't really make any sense, to be honest. There would be 0 sensitivity, so our ROC curve is actually really interesting. So if we change our sensitivity threshold if we wanted our sensitivity to increase, which is true positive rate, so if we wanted to have our sensitivity Wait, I'm saying this whole thing wrong. Forgive me for being such a nub. if we wanted our specificity to be 0.9, we would have to then the sensitivity would be around like 0.9 as well. This is almost 1-to-1, dude. This is almost moot point because we're still doing this on a full fit model, not some simulated cross-validated training and testing set. So hopefully that'll work out. Anyways, this is really good. I'm gonna save. I've already saved this. I saved this. Our next thing is that we're gonna use cross-validation to truly figure out if our true positive rate, it's gonna definitely be lower, but how much lower we want to know, because we want to lessen the, it's gonna be inevitably lower, but how much lower is like what counts. I hope it's not that much lower in terms of our true positive rates in general, but we'll see. Alright, I'll talk to you guys later. See you later, guys.